All right, welcome back. It's time for the next step. All right, we've got a basic spinner done. Now we're going to figure out how to do those little caps on there. So the caps are these little center things here, as you can see. And what they do is they allow us to hold on to this so it actually spins. All right, ooh, nice. I've got a few different types that I've experimented with so far. You can see you have ones that cover your bearings. All right, we've got ones that are a little extra thick that stick up a little bit. These kind of help sometimes if your hands are a little smaller. And you can see this one doesn't spin too well because I have one that was done improperly here that actually covers everything. Now the anatomy of the bearing itself, you can see right here that where we have this inner circle, okay? So we want our cap just to touch this inner circle and not to touch anything else so it can spin freely. If you have a large cap like that touches anything besides just this inside, it will drag on the spinner itself. And you can actually, I don't know if you can hear it, but I don't know if you really can hear that, but that's actually the cap dragging on the outside of that bearing surface itself. So what are the important measurements here? What do we have to know? We have to know that this is 7 millimeters thick. We have to know that I'm going to have something that looks like this, okay? And you can kind of see, I'm trying to hold it so you can see it. There we go. And you can see from the side view, there is like a little plug there, we can call it. And that fits inside. And the inside diameter that we have of these is going to be 8 millimeters. So we know that we need 8 millimeters to go in. We need a certain thickness of materials so that way this doesn't snap off or you could do it, print it completely solid, but I don't really think there's a point because it's so small. So that's not really going to break off. You can just save yourself time, printing time and material by doing that. And we need a thickness to this as well. Generally, the thickness, since we've been using, is between 1 and 200 thousandths of an inch. I made these about 1/8 of an inch or 125 thousandths. So I'll continue with that. That seems to work out pretty well. And we also have to know that what is the thickness of this inner ring, all right? Because that's going to be important because we don't want our spinner to drag on anything else. Something else, I don't know if you can kind of catch this if I get real close, but the spinner itself, you can kind of see how that inner ring kind of sticks out a little bit, and then the inside shielding that shields, okay, so this shielding in the center here, all right, so this is the shielding part right in here. So this is actually recessed a little bit. So we actually have all of this space to work with from the inside all the way through the shielding for our cap. But we don't want to touch this outside ring, right? So anything that touches that outside ring is going to drag. So let's take some quick measurements here. So the distance that we're looking for is that overall diameter of, let's just say, taking that measurement again, and we'll call that a diameter of 17 millimeters. All right, so let's make that 17 millimeters. So I have 17 millimeters I'm working with. I've got a 7 millimeter thickness that I'm working with. And that's about all we really need to know. Yeah, and we know that we're going to have 1/8 of an inch thick. So let's go ahead and get started. This is going to be pretty simple. I'm going to make some caps up here. So I'm going to share my screen, and I'm going to show you my inventor. And the first thing that we always do is start a new 2D sketch on the XY plane, and we're going to be starting off on the center. Now we know that we have an outside circle to work with here. And I'm going to start off by grabbing the center here, and I'm just going to say 17 millimeter circle, all right, which is 0.669. All right, and that's going to be the place where our thumb is going to rest, and I'm just going to extrude that 1/8 of an inch, or 125 thousandths. Okay, that's pretty simple. So this is going to be the base of what we need. The next thing that we need to know is going to be the internal diameter of the bearing itself, which we happen to know is 8 millimeters. So I can just grab this, place a new sketch. Since I'm already on the origin, it makes it easy for me. I know that this now needs to be 8 millimeters. There we go. Pretty simple. So that's 8 millimeters. That's an 8 millimeter diameter. Okay. and I need to extrude this. How far do I extrude this? Okay, so we know that the overall is 7 millimeters, but 7 millimeters was going to go all the way through. So if I do 7 millimeters divided by 2, all right, now both caps, when I insert them, they're actually going to barely touch each other. Okay, so this is actually, I would actually bring this back a little bit. So if I go back to, let's say, this extrusion, I'll give myself a little bit of leeway. So I'll make this 6.9, actually 6.9 millimeters divided by 2. And that way the caps don't actually physically touch each other on the inside, just in case we're off by a little bit of a tolerance there. And I'm going to be making these a little bit bigger, actually. Print everything a little bit bigger, actually 1% bigger, for a reason I'll tell you about later. And now I don't have to worry about anything dragging. If you wanted to do something a little different and more advanced, I'm going to go through and do that with you next time in the next design. But this is the absolute basics, okay? And that's what we're doing here. So what next? Well, what I would do is I would now give ourselves a little bit of fillet, because this we're going to have to force inside of the bearing, and it's going to be the same exact size. So I'm going to make this, give myself a 10 thousandths here. And actually, because I want to make sure that we clear, I'm actually going to give myself a 10 thousandths right there as well, just to make sure that it's not pinched up against the bearing. All right, so 10 thousandths is good. And if I want this to look good, all right, and I have this little thumb ramp here, I'm going to go ahead and I'm just going to fillet these two, and then you can go ahead and fillet this whatever you want. I've made it 0.125 inches, and I can do 125 divided by 2, and if I do that, you can see that I'll get a perfectly nice rounded, and both of those fillets will meet directly in the center, which is really nice. Okay, and there you have a real basic cap for your fidget spinner. And depending on the resolution of your 3D printer, you can also go ahead and emboss some information on here as well. But I'm going to be doing this on a standard resolution, and just by printing this upside down, I'm going to be printing it this way actually on my 3D printer, and so I'm not really too concerned about that right now. I'm just worried about this being nice and grippy. If you want to go ahead and maybe put some extrusions here, maybe cut another little circle or something out of here to give yourself more grip, go ahead and do that as well. But this is the basic. So again, I'm going to take this and then save that. And remember that I'm going to take this and export a new CAD format, which is a stereolithograph or an STL, and make that a test cap as well. And so now I'm ready with my fidget spinner and my cap to go ahead and 3D print. So I'm going to see you guys next time, and we'll be setting up the 3D printer. All right, hopefully that was helpful, and I'll see you next time.